following is a presentation of the TCS winning team in the sales and service area, choosing to represent Motorola Communication Israel in the 1992 International Group Competition. We wish good luck to all competing teams.
Hello, my name is Moti Parnes. I'm a product services manager for Motorola Israel, and I'm pleased to present the TCS presentation for MCIL QSR team. One of the main factors in total customer satisfaction is providing fast, efficient repairs that save the customer time and Motorola valuable resources. We established a QSR, quick service repair team, with members in all relevant areas to find ways to achieve this goal. The quick service repair team includes Rafi Rosen, technical manager in the service division, Yaakov Baron, computer division, Amnon Margalit, systems FTR, Yaakov Frender, service lab manager, Yitzhak Bar, products FTR. We chose our project based on Motorola corporate strategy of customer-driven quality services. The goal of our project was to drastically reduce the repair cycle time from matter of days to matter of hours, without having to keep the equipment in the service center. This performance improvement would lead to more satisfied customers, enhance our reputation, and lower repair costs for the company. The customer would not have to visit the service center twice and would not lose the use of their equipment for an average of 2 days. We decided to select a single product and implement our plan for this product by the end of May 1992 in the Tel Aviv and Ra'anana service centers. Our goal was to take the project nationwide to Israel's 13 service centers by the end of third quarter 1992. In order to meet the challenges presented by the project, our team held more than 25 decisive meetings. Each member was given specific tasks to complete, and a detailed record of the entire project was kept and is available. Choosing the right product for the quick service repair program was simplified when we viewed the distribution of the primary product mix in our market. As you can see, the MaxTrack, which offers conventional and trunking modes in the VHF, UHF 800 and 900 MHz, accounts for almost 39% of the main products found in our market. We decided that reducing the MaxTrack repair cycle would be an important achievement and a good model to build on. The team started the project by conducting a Pareto analysis of the MaxTrack's defects. Then we highlighted the defects that required leaving the radio in the repair center for an average of 1.8 days. As you can see in this graph, 44% of all MaxTrack faults required an average 1.8 days repair cycle time, 2 customer trips to the repair center, and significant radio downtime. We seriously considered 3 alternative repair methods to achieve our goals. Exchanging the defective radio with the working unit, exchanging boards, exchanging the radio's unified chassis, which contains everything but the covers and the front control panel. We looked at each alternative repair method from both the customer's and Motorola's standpoint using the following criteria: customer waiting time for the repair, hookup time to the US trunking management system, size of spare parts inventory, type of manpower required for the repair, changes in internal management and control systems. The radio should look the same, inventory control, possibility of tracking bounced repairs, lost airtime. In this table, we can clearly see that the third alternative, replacing the unified chassis, is the ideal solution, especially considering the time needed to repair the unit, changes to internal systems, and spare parts inventory requirements. In fact, just 11 types of unified chassis models needed to repair 36 different Max Truck models. Before implementation, the team held several brainstorming sessions and discovered a number of obstacles which were presented in a detailed cause and effect diagram. Concentrated teamwork then helped overcome these obstacles. The first problem concerned where to repair the unified chassis unit. The team decided that the most effective and efficient way would be to send defective units to the central service facility. The second problem concerned serial numbers. Thanks to special software adapted by Yaakov Baron, replaced chassis received new nameplates that retained the original Radios serial number. In virtually every case, customer-specific embedded software could easily be transferred from the defective unified chassis to the new one. This transfer eliminated the need to access the master trunking management system in the US. Careful investigation discovered no legal problems. By changing the unified chassis, we slashed the average repair time to just 60 minutes. But we were still not satisfied. We felt that the process could still be reduced and customers could get in and out of the repair center even faster. We started by developing a flowchart which detailed the improved repair process. We discovered that during the transfer of embedded software from one unified chassis to the next, the preset parameters, including power, deviation, frequency stability, etc., were erased. The technician had to spend 20 minutes reloading these parameters. Yitzhak Bar and the MCIL software group modified the RSS software used to program the radio and eliminated the need to retune the parameters after data transfer, cutting the customer waiting time by another 20 minutes, an extra 30% savings. MaxTrack can now be repaired in just 40 minutes, an overall cycle time reduction of 98%. Our customers wrote letters telling us how happy they were with the new speedy repair service. Now, our job was to tackle the internal changes resulting from our program. The team took measures to prepare the central lab for handling the unified chassis coming in for repair. We initiated a new software for an automatic test station operated by a known technical employee. The system, with programmed standard frequencies and parameters on every chassis that arrives for repair, determines defects, sets power and deviation across the radius range, performs final tests to repair units. This automation streamlined the entire repair process. The technician did not have to read radio parameters, search for faults, reset the test bench prior to each repair, install power, deviation, frequency stabilization parameters, and conduct a final test. Let's look at the results of the QSR program. We reduced the repair cycle time by 98%, from 1.8 days to just 40 minutes. The customer does not have to waste precious time coming to the repair center twice. The customer does not lose the use of a valuable business tool for a few days. The unified chassis is repaired at the central service center, enhancing quality and efficiency. The cost of the QSR repair is 25% less than the conventional method, based on the use of an installer instead of a technician at the service center, reduced inventory of spare parts and logistics, economies of scale resulting from centralized repair. But does it work? The answer is a resounding yes. The system has been up and running for 3 months at service centers which are responsible for 10,000 MaxTrack units. In fact, it has been so successful that we adapted it for the HT600 and GP300 products, and all 3 programs will be implemented nationwide by the end of September 1992. Looking to the future, we have already developed similar programs for the Jedi and Renaissance. To the best of our knowledge, our quick service repair method is unique and innovative. It can be easily implemented at Motorola repair centers around the world, enabling the company to save a lot of money and satisfy a lot of customers. For Motorola, the company where quality means the world to us. Keeping customers happy means also providing better, faster service. If the customers are happy with your product and your service today, they will come back in the future. That's total customer satisfaction. Thank you.
Hello everybody. Following is a presentation of the TCS winning team in the All Others area, chosen to represent Motorola Communication Israel in the 1992 International Group Competition. We wish good luck to all winning teams.
Shalom. Motorola products are software intensive. It is in the software that the customer-seen features are implemented, and the development of that software is always on the critical path. If software is the key to Motorola's success, it is clear that the development of that software must be optimized. But let's take a look at that critical path. When a new product is proposed, a development group will produce software. Another group with a similar product requirement will develop the same or similar software from scratch. Another group and more software. Again and again and again. This unnecessary effort is the problem we chose to solve. Software reuse reduces cycle time and the number of learning cycles and improves software quality. To solve this problem, we established the Software Reuse Pioneers team with representatives from each of the development groups within our division: SSD, fixed stations, alarm control, mirrors, portable and mobile products, and SSB. Since August of '91, our team has held over 50 weekly meetings. At these meetings, tasks were assigned and progress reported. Each meeting was summarized in a weekly report distributed to the team members and the management. Over the past year, subcommittees were established, and various activities were performed in parallel. Those activities which have been institutionalized will continue in the future. Our first task was project selection, and the project we defined was the institutionalization of software reuse, to integrate software reuse into the development process, and to create any tools and procedures that might be needed. The software development process consists of many phases: requirements analysis, design, coding, and testing. Software reuse must be an integral part of each and every phase. But what is software reuse? It is reusing proven software components in new projects. It is avoiding the waste of reinventing the wheel. It is looking at existing software components as software ICs, tested, high-quality components that can be used over and over again with little or no additional development cost. The advantages that software reuse provides are clear. By reusing existing, tested, and reliable software, we expect to shorten the development effort, reducing cost and cutting product cycle time. We'll also release a higher quality product with fewer defects. Another benefit of the reuse process is better cooperation and communication between software engineers. All of these increase customer satisfaction. George Fisher has called software our window of opportunity and has challenged us to create a new software culture that places Motorola at the top of the list of software providers. Software reuse is a new software culture. The analysis of the problem began with a brainstorming session, the results of which were recorded in a fishbone Ishikawa diagram. We perceived that the problem had its roots in many areas. For example, the human factors, such as NIH, where the engineering staff has no motivation to use software developed elsewhere. The existing set of software components, where differing styles and quality criteria prevent reuse. The current development process, where reuse is not considered, and in product considerations, where existing software is simply not reusable. To further clarify the needs of the development community, we conducted a survey whose goals were to benchmark existing reuse levels within the division, to determine the attitudes of the engineers to reuse, and to explore alternative approaches to increasing reuse. The results of the survey were clear. Very little actual reuse is being done, and where it is being done, reuse is informal, within groups, and almost exclusively during coding. This is despite the fact that most engineers consider software reuse important and practical in all phases of development. We identified several perceived obstacles to reuse, such as inconsistent and insufficient documentation, lack of confidence in software developed by other people, and poor communication between groups, which would normally promote software reuse. Our analysis of the survey showed three major opportunities to increase reuse: the creation of a database of reusable software components, incorporating reuse into the development process and preparing a handbook with practical reuse guidelines, and instituting a reuse incentive program. Based on our findings, we established goals for 1992. Our challenge was to make the MCIL software development community aware of the importance, feasibility, and benefits of the software reuse, to establish a database of reusable software components. This database would have at least 15 components. Further, we set a goal of $50,000 in cost savings based on actual software reuse. Finally, in order to institutionalize reuse, formal guidelines would be created and incorporated into the software development process. Based on benchmark data from other companies, we expect software reuse to increase by 5% each year. Further, we expect software reuse to cut cycle time by at least 25% over the next 5 years. MCIL will save over 90 person-years. By spreading the gospel of software reuse throughout Motorola worldwide, we expect to see a corresponding 25% reduction in cycle time and an overall savings of over $100 million in 1997. To achieve our goals, the TCS team used many parallel approaches. Regular columns in its LANU, an MCIL internal publication, Touch of Quality, and the corporate SOD walkthrough provided detailed, practical software reuse guidelines. As a result of our actions, software reuse at MCIL has been recognized internationally at such forums as Software 2000 and the Motorola Software Engineering Symposium. The Corporate Software Engineering Technology Committee, SET, Reuse Working Group, has cited MCIL as being on the forefront of reuse within Motorola. The formal specification of the reuse process and the creation of the reuse database was one of our major achievements. The reuse process works as follows. First, the software engineer completes a reuse form that fully describes the software component he created. This form and the proposed component are examined by the reuse committee for completeness, quality, and reusability. Only those components approved by Software Quality Assurance, SQA, are accepted and then added to the database. The submitting engineer is then rewarded for the extra effort in preparing the component and for agreeing to support that component in the future. Information on the new component is then distributed to Motorola engineers throughout the world. At any time, these engineers can access the reuse database to examine the approved components. When the component is actually reused, both the originator and the reuser are rewarded for improving quality and cycle time. After only 6 months, the results speak for themselves. Formal reuse guidelines have been written, which explain both how to write reusable code and how to reuse existing code. A copy of this handbook has been provided for your reference. 37 components have already been submitted. Of these, 23 have been approved and added to the database, while the remaining 14 are currently under review. To date, 8 cases of actual reuse have saved MCIL over $100,000, 20 person months. Our goal for 1992 of 15 components and $50,000 is already history. Assuming a steady increase, we now expect to see over 40 components and $200,000 in actual reuse by December. Let's look at an example of reuse in action. The development of a software component for the Astro project took the Fixed Stations group 24 person months. A similar component was required for the HLC 2000 project by the SSB group. Since the component had been cataloged in the database, SSB was able to locate and reuse that software, saving 17 person months. The net result is that the customer will receive the HLC 2000 1 year earlier. That's customer satisfaction. The Reuse Committee has been institutionalized as part of the MCIL Software Council and has the responsibility to administer the Reuse Incentive Program. The SET Reuse Working Group has assigned responsibility to MCIL for incorporating reuse into the software development process. We have developed metrics for tracking reuse, which are now part of the software ship acceptance process. Having met our goals, the reuse pioneers continue to advance the cause of software reuse throughout Motorola, and many other groups are now using us as their model. The MCIL factory has come on board and has already saved over $20,000 by reusing software. The semiconductor operation in Phoenix and the cellular group in Israel have requested our assistance in setting up their own branch reuse committees. John Major, chairman of the Software 2000 program, has commended the activities of our committee in showing real leadership in this area. It is our vision to achieve a global software database, allowing Motorola software engineers everywhere to reduce development time, increase product quality, and create better products. By bringing products and systems to market faster, at lower cost, and with enhanced quality, we will have achieved our goal: total customer satisfaction.
Hello everybody. Following is a presentation of the winning TCS team in the manufacturing area, chosen to represent Motorola Communication Israel in the 1992 International Group Competition. We wish best luck to all competing teams.
Judging committee and distinguished guests, in view of the increasing competition and the efforts made to decrease manufacturing costs, more and more attention is given to the subject of the freight cost. At MCIL, the cost of freight has gained further visibility with the introduction about 2 years ago of direct shipping to customers, mainly in the USA. Direct shipping to customer, as compared to shipping kits from a feeder plant to a backend facility, improve quality and cycle time and saves a lot of costs by eliminating double handling and testing, thus increasing total customer satisfaction. And it also made freight cost much more visible and significant. Many memos were written on the subject and many meetings were held with our forwarders and carriers to try and reduce the price by just a few %. Yet, The feeling persisted that this was not enough to satisfy our customers. And once we were talking about customer satisfaction, what better than to set up a TCS team to tackle the problem? One glance at the packing design and the shipping process chart is enough to see its complexity, involving many diverse entities in and out of the company. This was the guiding factor in forming the team. The team members were carefully selected to represent as much as possible all aspects of the process. Let me present them to you. Ahuva Basson, responsible for expediting and reporting in the shipping department. Galit Kahlon, responsible for planning and coordination of shipping in the shipping department. Adi Shani, representative of information systems. Shaul Hamisha, representative of physical design. Moshe Sinai, storekeeper in the consolidation warehouse. Jacob Beaton, quality assurance. And myself, Marco Aliman, the team leader and manager of the shipping, billing and reporting department. The team met regularly once a week, starting in January 1992. To express our aim, we chose the name The Cheaper Shipper.
It was clear to us that freight costs are high and we are indeed facing a problem. But it was difficult to estimate its magnitude and to trace its source. To define the problem, we mapped the process and saw that the task was difficult since it involved many entities: marketing, physical design, packing manufacturer, packing departments, ground carriers, forwarders, and air carriers. To facilitate the gathering of data, we decided to focus on shipments to the US, which represent 85% of all export shipments. We then prepared a fishbone diagram, cause and effect, to identify those factors influencing costs. An analysis of the expenses Pareto showed that in 1991, air freight expenses amounted to 85% of total shipping costs. Therefore, we decided to concentrate on reducing the cost of air freight. At this stage, we had identified the problem, but were unable to estimate its magnitude. One thing was clear: the basis for calculating air freight charges is the weight of the shipment or its volume, whichever is larger, at a ratio of 1 to 6. That means that 1 kilo in weight is equal to a volume of 6 liters. A little more optimistic, the team turned to acquiring data of air freight costs. We checked all 1991 shipments to the US and found that a total of 349 tons had been shipped, but 495 tons had been paid for. From this difference between weight shipped and weight paid for, it can be seen that in 1991 we paid for shipping 146 tons of oil and air, which is 42% addition to air freight costs. In addition, we did a benchmarking of shipments by other companies similar to us and found similar results. We were all in the same boat. Since we are not in the business of exporting air, not even oil and air, the team concluded that reducing package volume will save a significant sum in air freight expenses and will correspondingly increase the satisfaction of the customer who bears this expense. In view of the above data, the following task was defined: reduction of air volume in shipments by 50%. Once we added data, we rechecked the process and came to the following conclusions. Packings are designed to successfully pass the packing test, and once this is achieved, no attempt is made to optimize the weight-volume ratio. When consolidating in larger containers in the packing area, there are no means for selecting the optimal packing. The packing 12M spec does not mention the packing's volume. There are cases of double packing. There is not enough coordination between the marketing, engineering, and shipping departments that influence the process, and they are not aware of freight costs. This initial conclusion made the team decide to tackle the problem on 2 levels: set guidelines for planning optimal consolidation packing in accordance with the principle of optimal weight-volume ratio, identify and revise the most costly product packing in order to set an example for all other products. Now that the team had studied the process and the problem and was thoroughly familiar with both, we gathered for a brainstorming session to find a way to identify the problematic packings. And then it came. One of the team members tossed the idea of adding a cost coefficient on the computerized shipping system screen. This would hold the weight-volume ratio formula, and by means of a light flashing on the screen would warn us when we packed wastefully. That is, the volume of the package converted to weight exceed the actual weight. After several field experiments, we found that the warning light flashed too late when the equipment was already packed. So we decided to add another warning point at the start of the packing process. And then came another idea. In the packing department, consolidation packing are known as half containers, quarter containers, and so forth. We decided to give them numerical names to express the weight volume charge paid for them. For example, we renamed the half container packing the 100 packing, and the quarter container the 46 packing, and so on. For the sake of practice, we placed a large sign next to the scale showing all the types of packing with the relevant numbers. The result was, to quote one of the employees in the warehouse, "I am ashamed to pack 60 kilos of equipment in 100 packing. Why should the carriers have a profit of 40 kilos at our expense?" This idea led us to place an additional scale at the start of the packing line. With this scale, the net equipment is weighed, and the most efficient consolidation packing from the volume point of view is selected accordingly. From here on, and especially after we managed to infect all other employees with our own enthusiasm, we acquired additional experience and data with the help of the flashing light at the end of the packing line, and we decided to act immediately to reduce the excess volume in the half-container packings, which proved to be particularly wasteful. We achieved this by introducing a variety of new medium-sized consolidation packings, whose immediate impact was to reduce freight costs from an average of $3 per kilo to $2.4 per kilo for the months of May, June, and July of this year. These results were obtained by reducing the excess volume by 60%, which meant a reduction of 20% in consolidated consignment freight costs. Now we turn to reduce the weight-volume ratio of individual product packings. The packing chosen was the packing of the desk truck, which was caught daily by our flashing light radar. This packing was identified as the most wasteful one, where the customer paid $4.7 per kilo instead of $2, which is the agreed freight tariff. Searching for ways to reduce the volume of the desk truck packings, we looked into the reasons that led to this particular design and found that indeed there was a problem. The unit is made of plastic and there's a very heavy power supply mounted in it. In order to protect it while in transit, the designer had to allow for a large buffer space which considerably increased the packing volume. This information convinced us that if we could succeed with such a problematic unit, there was nothing to prevent us from tackling all other products. In parallel, we searched for new cushioning material that could provide improved protection at minimal dimensions. We finally selected corner mat absorbers for the inner cushions. Anxious and fearful, we submitted the unit to the inquisition of the environmental test lab and requested testing in stages. Very early we found that the support for the front panel had to be added. Equipped with the corner mat absorbers and the additional support, the unit passed through the entire test procedure, coming back whole and intact. Gathering confidence, we became more daring, and since corner mat has to be imported, we decided to build polyurethane corner cushions with properties similar to corner mat as a cheap substitute available in-house. Once again, we advanced cautiously until this packing also passed all tests successfully. At this moment, the team can announce from this stage that the excess volume of the desk truck packing had been reduced by 87%, and in terms of shipping weight, the customer will now pay $2.35 per kilo instead $4.7, which is 50% freight cost reduction. Based on an annual forecast of 3,000 units, customer freight costs have been reduced from $240K to $120K. And all this for only one product. To sum up, against the goal that we set ourselves, the following results were obtained. Reduction of air volume, 60% in the consolidation containers, 87% in desk truck packings, which means reduction in freight cost, 20% for consolidation containers, 50% for desk truck unit packings. In view of these impressive results, we implemented new guidelines for our physical designers. We will continue to analyze other product packings for improvement of weight-volume ratio. We will approach the parent company with a proposal to revise the packing 12M spec to relate to the weight-volume ratio. This is the Shipper Cheaper team's contribution for saving money to our customers and to lead to a greater customer satisfaction. Thank you very much.